Imagine a computer so powerful that it could solve problems in minutes. Problems that would take classical computers billions of years. This is the promise of quantum computing, a revolutionary technology poised to transform our world. Unlike classical computers that rely on bits, quantum computers harness the bizarre laws of quantum mechanics. They employ qubits, which can exist in multiple states simultaneously, unlocking unparalleled computational power. Quantum computing is not just an incremental improvement, it's a paradigm shift. The potential applications span countless fields, from medicine and finance to materials science and artificial intelligence. With quantum computers, we could design life-saving drugs, create unbreakable encryption, and develop advanced materials with unprecedented properties. Just as bits are the heart of classical computing, qubits lie at the core of quantum computing. These quantum bits possess the remarkable ability to exist in a superposition, simultaneously representing 0 and 1. Get ready to explore the fascinating world of quantum computing, where the seemingly impossible becomes possible. At the heart of a quantum computer lies the qubit, the quantum bit. Unlike classical bits, which are either 0 or 1, a qubit can be in a superposition. This means it can be both 0 and 1 at the same time. Imagine a coin spinning in the air, not yet landed. That's superposition. This mind-bending property is what gives quantum computers their power. A single qubit can perform multiple calculations simultaneously. As you add more qubits, the computational power grows exponentially. Just a few hundred qubits could outperform all the classical computers on Earth combined. This opens up a universe of possibilities for solving complex problems. However, qubits are extremely delicate. Scientists are working tirelessly to overcome these challenges and unlock the full potential of quantum computation. Entanglement is another bizarre phenomenon in quantum mechanics that plays a crucial role in quantum computing. When two qubits become entangled, their fates become intertwined. They become linked in a way that transcends physical distance. Measuring the state of one entangled qubit instantly reveals the state of the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. This interconnectedness is a valuable resource in quantum computing. Entanglement allows quantum computers to perform computations in parallel across multiple qubits. It's like having multiple processors working together on a single problem, but on a much grander scale. Entanglement also plays a vital role in quantum communication and cryptography. By sharing entangled particles, two parties can establish a secure communication channel. Scientists are continuously discovering new ways to harness entanglement for building more powerful and efficient quantum computers. Imagine a world where diseases are diagnosed with incredible accuracy, drugs are designed with unparalleled precision, and personalized medicine becomes the norm. This is the promise of quantum computing in healthcare. Quantum computers have the potential to revolutionize medicine as we know it. One of the most promising applications of quantum computing in medicine is drug discovery. Designing new drugs is a complex and time-consuming process. Quantum computers could accelerate this process by simulating molecular interactions with incredible accuracy. This could lead to the development of new drugs for diseases that are currently incurable. Quantum computers could also revolutionize medical imaging. Techniques like MRI and CT scans could be significantly enhanced, providing doctors with clearer and more detailed images of the human body. Personalized medicine is another area where quantum computing could have a profound impact. The marriage of quantum computing and medicine holds the key to a future where healthcare is more precise, personalized, and effective. Quantum finance, reshaping the financial landscape. The financial industry thrives on analyzing vast amounts of data and making predictions about market trends. Quantum computing is poised to revolutionize finance by providing unprecedented computational power. This could lead to more accurate risk assessments, optimized investment strategies, and enhanced fraud detection. One of the most promising applications of quantum computing in finance is portfolio optimization. Quantum algorithms can analyze vast amounts of financial data and identify optimal investment strategies. This can help investors maximize returns while minimizing risks. Quantum computers could also improve risk management significantly. They can analyze complex financial models and simulate market scenarios with a level of detail that is impossible for classical computers. Fraud detection is another area where quantum computing can make a significant impact. The integration of quantum computing into the financial landscape has the potential to reshape the industry. Decrypting the future quantum computing's impact on cybersecurity. In today's digital age, cybersecurity is more critical than ever. As we rely increasingly on online platforms for communication, commerce, and critical infrastructure, the need for robust cybersecurity measures becomes paramount. While quantum computing presents exciting opportunities, it also poses significant challenges to our current cybersecurity infrastructure. Most of today's encryption algorithms rely on the difficulty of factoring large numbers, a task that is extremely challenging for classical computers. However, quantum computers excel at this task. A sufficiently powerful quantum computer could break many of the encryption methods we currently rely on, jeopardizing sensitive data. Researchers are already working on quantum-resistant encryption algorithms that can withstand attacks from both classical and quantum computers. These new encryption methods will be essential for securing our data in the quantum era. The race is on to build quantum-resistant encryption methods before large-scale quantum computers become a reality. Materials, science, and drug discovery, a quantum leap forward. Quantum computing is not just about crunching numbers faster, it's about understanding the world at its most fundamental level. This understanding has profound implications for materials science and drug discovery. Quantum computers could revolutionize these fields by simulating and predicting the behavior of molecules with unprecedented accuracy. Designing new materials with specific properties is a complex and often serendipitous process. Quantum computers could change that. By simulating the behavior of atoms and molecules, scientists could design materials with tailored properties, such as enhanced strength, conductivity, or heat resistance. This could lead to the development of revolutionary new materials for a wide range of applications. In drug discovery, quantum computers could accelerate the process of identifying and developing new drugs. The ability to simulate and manipulate matter at the atomic level opens up a world of possibilities for materials science and drug discovery. While the potential of quantum computing is undeniable, several challenges remain before this technology becomes mainstream. One of the biggest challenges is building quantum computers that are large and stable enough to tackle real-world problems. Qubits are extremely fragile and susceptible to environmental noise, which can cause errors in computations. Maintaining the coherence of qubits for extended periods is crucial for performing complex calculations. Scientists are developing error correction techniques to overcome this challenge. Another challenge is scalability. Building quantum computers with a large number of qubits is extremely difficult. As the number of qubits increases, so does the complexity of controlling and entangling them. Despite these challenges, progress in quantum computing is accelerating. The race is on to achieve quantum supremacy, the point at which a quantum computer can outperform the most powerful classical computer on a specific task. The future of quantum computing is brimming with possibilities. As this technology matures, it has the potential to revolutionize various aspects of our lives, from healthcare and finance to material science and artificial intelligence. While it's difficult to predict the full extent of its impact, we can envision a future shaped by the transformative power of quantum computing. Imagine a world where diseases are diagnosed and treated with unprecedented speed and precision. Quantum computers could analyze vast amounts of genomic data, enabling personalized medicine tailored to each individual's needs. New drugs and therapies could be developed at an accelerated pace, leading to breakthroughs in the fight against cancer, Alzheimer's, and other debilitating diseases. In the realm of materials science, quantum computers could pave the way for the creation of revolutionary new materials with tailored properties. These materials could revolutionize industries ranging from aerospace and transportation to energy and electronics. Quantum computing could also revolutionize artificial intelligence. Quantum algorithms could enhance machine learning capabilities, enabling AI systems to learn from data more efficiently and make more accurate predictions. The quantum future is a future of boundless potential, a future where the impossible becomes possible. The convergence of quantum computing and artificial intelligence, AI, holds immense promise for revolutionizing various fields. Quantum computers can supercharge AI algorithms, leading to exponential advancements in machine learning, data analysis, and problem-solving capabilities. One area where this synergy is particularly impactful is machine learning. Quantum machine learning algorithms can analyze vast datasets and identify patterns much faster than classical algorithms. This can lead to the development of more accurate and efficient AI models for a wide range of applications, from image recognition and natural language processing to fraud detection and drug discovery. Quantum computers can also enhance AI's ability to solve complex optimization problems. Many real-world problems, such as logistics, finance, and resource allocation, involve finding optimal solutions from a vast number of possibilities. Quantum algorithms can explore these possibilities simultaneously, finding optimal or near-optimal solutions much faster than classical methods. Quantum neural networks, inspired by the structure of the human brain, can process information and learn from data in ways that mimic the brain's cognitive abilities. The synergy between quantum computing and AI has the potential to unlock new frontiers in artificial intelligence, leading to more intelligent, efficient, and capable AI systems. Quantum computing is no longer a futuristic concept confined to research labs. It is rapidly becoming a reality, poised to transform industries and reshape our world. While challenges remain in building large-scale, fault-tolerant quantum computers, the progress made in recent years is undeniable. As we venture further into the quantum realm, we must embrace the transformative power of this technology while addressing the ethical and societal implications that come with it. Quantum computers have the potential to solve some of the world's most pressing problems, from developing new drugs and materials to combating climate change and advancing artificial intelligence. However, like any powerful technology, quantum computing can be misused. It's crucial to establish ethical guidelines and regulations to ensure that this technology is used responsibly and for the benefit of humanity. We must ensure that the benefits of quantum computing are accessible to all, not just a select few. By embracing this transformative technology and guiding its development responsibly, we can unlock its full potential and create a brighter future for all. The journey into the quantum realm promises to be an exciting and challenging one, filled with opportunities to advance human knowledge and redefine the boundaries of what's possible.